The sum of an indicated number of terms in a sequence is called a series. And if the sequence under consideration is an arithmetic sequence, then sum of the terms of arithmetic sequence will be called arithmetic series. So let us consider a sequence with first term as a and common difference d. Let us consider AP, mean arithmetic progression, with first term as a and common difference as d. Then what will be the arithmetic sequence? This arithmetic sequence would be a, and the next term would be a plus d, the next term would be a plus 2d, and next term would be a plus 3d. Similarly, we continue onward, and the last term would be an, and term just before that would be an minus d, and the term before that would be an minus 2d. So this way we can write an arithmetic sequence. If Sn denotes the sum of n terms, if Sn denotes the sum of n terms of arithmetic sequence, mean AP, then we can write Sn equal to sum of these terms. Sn is equal to a plus d, and the next term would be a plus 2d, next term would be a plus 3d, and so on. And the third last term would be an minus 2d plus an minus d, and the last term would be an. So we can write this as sum of all the n terms of the sequence. Now if we write the same thing just using another arrangement, Sn could also be written as, instead of writing from first to last term, this time we are going to write from the last term first, and then the second last, and then the third last, and we'll start coming back toward the first term. So this would be an, next term would be an minus d, and the next term would be an minus 2d. And similarly, if we continue onward, we'll reach to the second term, which would be a plus 2d, and the next term would be a plus d, and the next term would be simply a. Let us call this as 1 and call the second arrangement as 2. It's just we wrote these sum of n terms in a different arrangement. It doesn't change their value. Now by adding 1 and 2, by adding 1 and 2, if we add, we can see that this plus d will get cancelled with minus d, plus 2d will get cancelled with minus 2d, minus 2d will get cancelled with plus 2d, minus d and plus d will get cancelled. So what we will be left with is Sn plus Sn, means 2Sn equal to a plus an for the first sum and a plus an again for the second sum, a plus an for the third sum, and this way we continue onward. Each time we get a plus an and again a plus an. This way we get n times a plus an. Let's write this down as well, a plus an. And because a plus an is being added n times, so just like x plus x plus x, if we add x 3 times, we can write it as 3x. The same way we can write 2Sn equal to n times a plus an, because a plus an is being added n times. So that's how we can write. And now by substituting, and also we know that an is equal to a plus n minus 1 into d for AP, arithmetic progression. So we are just going to substitute that value. This means 2Sn is equal to n times a plus value of an is equal to a plus n minus 1 into d, and now if we add them up, this will be 2Sn equal to n times 2a plus n minus 1 into d, and if we divide both sides by 2, Sn is going to be equal to n by 2 times 2a plus n minus 1 into d, which is required formula for arithmetic series, which is sum of n terms of AP. And this provides us the formula with first term a, with first term as a, and common difference as d. Now we can apply this formula to find sum of n terms or whatever number of terms we want to sum. So let's do a question. Here example 1 is, if we take a look on this example, there is a given series -8 -3 whole 1 by 2 plus 1, and we are required to sum up to 11 terms. So let's do that. Sum the series -8 -3 whole 1 by 2, then 1 up to n terms. Rather, there are only 11 terms. That's to 11 terms. So this time we are given, because if you look at the question, it requires only up to A11. So now for this series, what is the first term? The first term is a, which is equal to -8, and for common difference d, we can always subtract first term from the second term, that is -3 whole 1 by 2 minus -8. Either you can get d this way, or you can also subtract second term from the third term, or d is equal to 1 minus 3 whole 1 by 2. Both way d must be same. and we will do this just for the verification purpose. Otherwise you can only do for term 1 and term 2. By changing this into improper fraction, this will be multiplied with -3, and then you can add the numerator. So this will be -7/2, and this minus time minus will become plus 8, and if we take the LCM, which is 2 here, this will be -7 plus 16, and this will give us value of d equal to 9/2. This is value of d, and if we have used other one, this will be 1 plus 3 whole 1/2, because negative time negative is plus, and 1 plus 7/2 like before is equal to 2 plus 7/2, which is, you can see again, 9/2. So there is no difference. Whichever way you calculate d, you can calculate d, and it will be same. We got the first term, we got the difference d, and we also have n. N is 11, because we only want to find sum of 11 terms, and now what we want is S11, means sum of 11 terms, using the formula, using Sn. This is formula which is used, is equal to n/2 into 2a plus n minus 1 into d. To calculate the sum, we can substitute the values, which is equal to 11/2 into 2 times a. What is value of a? Value of a is -8. So let's substitute that value, -8 plus n is again 11 minus 1 times d. d we have just calculated, that is equal to 9/2. And let's close the bracket and perform the indicated operations. This will be equal to 11/2 times -16 plus 10 times 9/2. So this will be equal to, if you can close the bracket, and now 11/2 times -16, and you can cancel 2 5 times, and 9 times 5 is 45. So 11/2, again 11/2 times, this would be 29. And now you can multiply 11 times 29, that would be equal to 319 over 2, and if we divide, this will be equal to 159 whole 1/2. This is sum of the 11 terms of the given series. Let's take a look on second question, for which we are required to find the sum. The second is given, that's x minus a, x plus a, and x plus 3a, and so on up to n terms. So what is the first term? The first term for example 2, a is given, this is equal to x minus a, and d is something that we can calculate. We can calculate it by subtracting first term from the second term. The second term is x plus a minus x minus a, the first term. This would give us x plus a minus x plus a. Minus x and plus x will get cancelled, and this will give us value of d as 2a. Now we have a as well as d. N is given that we are required to find sum of n terms, so n is n, and let's find Sn. We'll use the same formula to find the sum of n terms using Sn equal to n by 2 into 2a plus n minus 1 into d. Let's substitute the values. This will be n by 2 into 2 times a. The first term is x minus a. Therefore, it will be x minus a plus n minus 1 times d. And d here is 2a. 2a. Let's close the bracket and n by 2 times 2x minus 2a plus 2an minus 2a. And if we simplify this, this would be equal to n by 2 into 2x and plus 2an minus 4a. And from this, if we take 2a common, this will give us n by 2 into 2x plus 2a into n minus 2. n minus 2. And now if we take 2 common and then divide with 2 outside, then this would be n times x plus, this would be n times x plus n minus 2 times a. That is value of the sum of n terms of the given series. Now the last question we are given in this lesson is example number 3. Sum the series. Sum the series. What is the series being summed here? That's 1 over 1 plus x plus 1 minus x. Okay, 1 plus x. So 1 over 1 plus x under root plus 1 over 1 minus x plus, again it's given 1 over 1 minus under root x plus so on up to n terms. If this is the series that is given, then let us calculate d. For d, we can use the same method, like subtract first term from the second term. So this would be 1 over 1 minus x minus 1 over 1 plus under root x. Now we can factorize this first fraction, which is 1 over 1 minus x. If we take a look on these fractions from algebra, we can write this as square, and this can be equal to 1 minus under root x times 1 plus under root x. Here this was 1 minus x equal to this. A bit tricky, but that's how we can factorize. This can be written as 1 minus under root x times 1 plus under root x minus 1 over 1 plus under root x. Now if we take LCM, that would be 1 minus under root x times 1 plus under root x, and both of these will get cancelled and leaving behind 1, and for the second fraction minus 1 plus under root x will get cancelled and we will be left with 1 minus under root x. So this will give us, this will be equal to 1 minus 1 plus under root x over, again we multiply and we make it 1 minus x, because the purpose is already fulfilled. The reason why we factorized it, it's already done. So d is equal to under root x over 1 minus x. If you were to subtract second term from the third term, we will still get the same answer. So if this is equal to d, and we already have a is equal to, a is the first term, and that is 1 over 1 plus under root x. So this is 1 over 1 plus under root x. We got d, we got n is equal to n, and we want to find out Sn. We simply use the formula. Now using Sn equal to n by 2 into 2a plus n minus 1 into d. We can use this formula and we can find the sum. This will give us Sn equal to n by 2 into 2a. A is 1 over 1 plus under root x plus n minus 1 into d, and d we have just calculated, that is equal to under root x over 1 minus x, and we close the bracket. And now this will be process of simplification for this thing here. This Sn is going to be equal to n by 2 into 2 over 1 plus under root x plus n into under root x over 1 minus x minus under root x over 1 minus x. So this is the value, and now we can simplify this first and the second term. This Sn is equal to n by 2 time. For the same reason, we are going to make factors n into under root x over 1 minus under root x and 1 plus under root x minus under root x over 1 minus x, and this way we can cancel out some of the stuff. N by 2 into 2 times 1 minus under root x plus n into under root x over 1 minus x minus under root x over 1 minus x. So now we can simplify this, but as long as this is the sum and we are not required to produce any specific expression for the sum, we can leave the answer at any stage. For simplification, this is equal to 2 minus 2 under root x plus n into under root x minus under root x over 1 minus x. So now this is how we can simplify this, and this is equal to n by 2 time 2 minus 3 into under root x plus n into under root x over 1 minus x.